Hello students. तो previous class रे देखी the potential electric potential due to a system of charges by number of point charge. Clear? If there are number of point charges, then we can find out the potential at a point due to number of charges by using the principle of superposition. Clear? The principle of superposition कौन कहती है? The net potential at a point due to the number of charges is the sum of the potential at point P due to the individual charges. I mean the sum करिवा केमती sum करिवा by scalar जेहेतु potentials are scalar quantity, they can be simply added by algebraic rules. Clear? तो आज देखिवा the potential at a point due to a continuous charge distribution. Potential at a point potential at a point due to a continuous charge distribution. Continuous charge distribution. Clear? The potential at a point due to a continuous charge distribution. The continuous charge distribution हमें आगुरी जानी चाहिए electrostatic रे पढ़े थिली. The charges are distributed in three different ways. One is the linear charge distribution, surface charge distribution, and volume charge distribution. Whatever may be, से linear हो कि surface हो कि volume हो. Suppose this is a linear charge distribution. हला This is कौन कहते surface charge distribution. This is the surface. The charges are distributed over this length. The surface are distributed throughout this surface area, and this is the volume. Suppose this is the volume. Clear? The charges are distributed throughout the volume of the this. So how can you find out the potential at a point? Suppose this is a point P. Yes, this is the point P. This is the point P and this is a point P. Then how can you find out the potential at point P due to this charge? Hello, this is the charge from this to this. This is a charge throughout this surface. This is the charge throughout the volume. How can you find out? Now for that we consider a small element. Yes, we consider a small element. Hello, we consider a small element. Let it be dq. This is suppose the charge of this element dq. Similarly, we consider this surface, the charge here dq, and we consider a small volume. Clear? Hello? हाँ मु देखी जीबी कारण बर्तमान तो अच्छी क्लास अच्छे. हाँ क्लास अच्छे मुझे हम 5:30 पर जीला. हाँ ताले एटा किए dq. This is suppose we consider a small element and this element has charge का ताला dq. Now this is the point, let it be r, and this is the point, let it be r, and this is the point, let it be r at a distance. So how can you find out the potential at point P due to whole of this element, whole of this distribution of charge? Now we can find out the first. This is considered a point charge. Clear? This element is considered as a point charge. If this element is considered a point charge, then what is the potential at this point? Hala, then potential at point P, potential at point P. The potential at point P due to the element, element you know, the small, due to the element of charge, let it be dq. The potential at point P due to the element of charge like dq, element of charge dq. Clear? ताले केते गेला dv is equal to yes 1 by 4 pi epsilon 0 dq by r. You know, हमें काली बाहर करते ले potential at a point due to a point charge. we know potential at a point due to a point charge 1 by 4 pi epsilon 0 q by r. Here q, this is the element, this element is considered a point charge whose charge is dq. dv is equal to 1 by 4 pi epsilon 0 dq by dr. Then how can you find out the total? Then the total yes, total potential at p due to total potential at point p hela tale kete paiba total potential due to the charge, all charge distribution due to the potential at point p, integration of dv, yes, integration of dv, integration of 1 by 4 pi epsilon 0 dq by r. Clear? Then we can write, this is called dv, that is called total potential of v, 1 by 4 pi epsilon 0, and dq, this is the integration of dq by r. Clear? Integration dq by r. Then what is dq? Where dq f, if it is a linear charge distribution हमें कौन लिखिबा ताले dq लिखे हमें कौन जाच lambda is equal to हला dq by dl हला if the charge is length हला dl then dq by dl ताले dq केते गला lambda into dl हला for linear charge distribution. Similarly, this can be written as sigma into ds for surface charge distribution, and this is equal to rho dv volume charge distribution. Clear? Then put the values and find the answer. Hala? So this is your potential at a point due to a continuous charge distribution. Hala? ताले आम जानी पॉइंट चार्ज सिस्टम ऑफ चार्ज रो एबे हम बाहर करे कौन बाहर कले ने कंटीन्यूअस चार्ज डिस्ट्रीब्यूशन. तो नाउ एबे हम बाहर करिबा द इलेक्ट्रिक पोटेंशियल एट ए पॉइंट ड्यू टू ए इलेक्ट्रिक डाइपोल, ड्यू टू एन इलेक्ट्रिक डाइपोल. तो इलेक्ट्रिक डाइपोल, यू नो इलेक्ट्रिक डाइपोल हाला इलेक्ट्रिक पोटेंशियल at a point, electric potential at a point due to an electric dipole, due to an electric dipole, electric potential at a point due to an electric dipole. Clear? You know what is the dipole? Yes, dipole is nothing but it is a system that consists of two equal and opposite charges separated by a distance. Hello? And the distance between the two poles is known as the dipole length. You can write 2a, and the line joining the two poles is known as the axial line, and the line that is perpendicular to the axial line and passing through the center, you know that is your equatorial line. Now you find the electric potential at a point due to an electric dipole. Hello? Suppose this is your electric dipole. Clear? So this is a minus q and this is your plus q. Hello? This is your plus q. Two equal and opposite charges separated by a distance. Let it be this distance like 2a, and this is the center of the dipole. Hello? So let this is equal to a, this is equal to b, and this is equal to o. Center of the dipole kete o, and this distance is equal to 2a. Clear? 2a. Now to find the potential at a point due to this dipole, let p is the point of observation. Suppose this is the p, this is your p, which is at a distance r from the center of the dipole. P is by any position, and it is our position vector kete, let it be r vector. Position vector kete r vector, but this is the magnitude kete gala r. The length from, but distance from origin go to O to P is equal to r, and it makes an angle, let it be theta. But this position vector that makes an angle ka se the axial line is kete theta. Then what is the field intensity at point P? How can you find out? Sorry, electric potential at point P. তাহলে P रे electric potential किन बार करिबा देखिबा एठी P जगह केतेटा field अछि. There are two charges, two fields are there. One is the field due to minus q, one is the field due to plus q. Then first we have to find out the potential at point P due to minus q kete, field potential at point P due to the plus q kete. Hala? Then how can you find out the potential at point P? This is the 1 by 4 pi epsilon 0 q by r. Q means that is the source charge that creates the field. It may be positive charge, it may be negative charge. R, that is the distance from the charge to the point of observation. So using this formula, we can find out the potential at point P due to minus q and plus q separately. Then by using the principle of superposition, we add these two potentials simple by algebraic rules to get the total potential at point P. Clear? Now find out the potential at point P due to the individual charges. Hello. So let us consider let us consider an electric dipole. Let us consider an electric dipole of charge electric dipole of charge plus minus q and dipole length to a and dipole length to a. So what is the dipole moment? So dipole moment yes, dipole moment P is equal to charge into dipole length, that is equal to 2a q, and it's directed from this to this. We don't bother about the direction because the scalar amara ethi kon rehla ame bahar kare jaଉche k, that is the potential which is a scalar quantity. Then the potential the dipole moment P hela kete 2aq. Now find the potential at point P due to minus q and find the potential at point P due to plus q. Hala? So what is the potential at point P due to minus q? Suppose the potential hela kete V1. Clear? So if V1 and V2, if sorry, so first point karo. So potential at point P due to minus q, so potential at P, how? Mane karo, etala kiye, that is the R is the distance, let P be the point of observation, let P be the point of observation, P be the point of observation, P be the point of observation at a distance kete R from the center of the dipole, from the center of the dipole and makes an angle theta with the capacitor dipole length and the position vector and the position vector hala, makes an angle theta with the axial line by dipole axis, with the axial line, with the axial line. Clear? Next, tale P hela kiye, that is the point of observation. P hela point of observation, yes, which is at a distance r from the center of the dipole, and this position vector is kete gala r vector. Clear? And this position vector makes an angle theta with the axial line of the dipole. Next, suppose find the potential at point P due to this V1. Tal jetebale ame eti sorry minus q, tal jetebale ame potential bahar kariba, tal we need the distance from this q by r. R means that is the distance from this to this, and When we find the potential at point P due to plus Q, we find the distance this. Clear? So this is the distance R, and this distance that is called kete gala AP, and this distance kete gala BP. So we find out the distance from A to P kete and distance from A B to P kete. How can you find out the distance? Now extended it from the geometry figure. So I am extend kar diya this line and draw a perpendicular. Yes, draw the perpendicular. This is the perpendicular. Draw the perpendicular. And similarly, we draw the perpendicular. Hela mane kare itala AM, and this is your BN. Hela tale itala ke AM and BN. Draw the perpendicular AM and BN on kaha pare extended OP. Hela tale from the geometry figure, but draw a perpendicular. Draw the perpendiculars AM and BN on extended OP. Clear? তাহলে OP উপরে আমি কোন কলে AM और BN परपेंडिकुलर टाणिले তাহলে এবে দেখো তাহলে বর্তমান এটা কেতে তাহলে AP is equal to কেতে গেলা this এটা হলো কি AP AM ହେଲା তাহলে in the triangle APM, in triangle APM তাহলে বর্তমান কোন হবে বর্তমান তাহলে এইটা কেতে রে in triangle this, suppose this angle theta, তাহলে this angle is theta. in triangle AMO, in triangle AMO ହେଲା this theta হলে OM কেতে গেলা তাহলে OM is equal to দেখো এইটি দিকেতে this is the length of dipole 2A, তাহলে এইটি দিকে যেটা সেন্ট্রাল এটা হলো কেতে A, তাহলে এটা কেতে হলো এটা হলো A, this is theta, তাহলে এটা হলো কি A cos theta, তাহলে OM is equal to A cos theta. in triangle AMO তাহলে কেতে হলো OM is equal to A cos theta. Similarly, in triangle BNO, তাহলে বলতাম দেখো এটা কেতে তাহলে ON is equal to A cos theta. যেহেতু this is equal to A and this is theta, তাহলে this component এলা কেতে A cos theta. Clear? Now find what is AP. তাহলে AP is equal to now AP is equal to কেতে গেলা AM, AP is equal to PM, so this can be written as PO plus OM, PO is equal to R plus OM A cos theta. Clear? তাহলে AP is equal to PO plus OM, PO is equal to R and this is equal to A cos theta, তাহলে R plus A cos theta. Then B এবে বার করিয়া কেতে BP, তাহলে BP is equal to কেতে তাহলে BP is equal to S, BP is equal to কাছে দাও PM, তাহলে this is equal to তাহলে PN that is equal to PO minus of ON, তাহলে that is equal to PO লাগাতে R minus ON লাগাতে A cos theta. Clear? তাহলে AP is equal to R plus A cos theta, BP is equal to R minus A cos theta. Hala? So now we find the potential at point P. So how can you find out potential at point P? Clear? Hala? So I am call pai gale AP pai gale, then BP pai gale. Ebe amar darkar potential at point P due to minus Q and potential at point P due to plus Q. लिखवा ताले potential at point P due to minus Q, ताले potential potential at P due to minus Q. So let it be V1. Suppose we consider V1 or V minus Q. The potential at P due to minus Q. So what is yes, 1 by formula 1 by 4 pi epsilon 0. Then Q है लाइक सोर्स चार्ज कौन अच्छी minus Q divided by R it क्या distance from this to this, that is equal to AP. So we can write minus 1 by 4 pi epsilon 0 Q by एटा केते थिला R plus A cos theta, R plus A cos theta हला. This is the potential at point P due to the minus Q charge. Then we find the potential at point P due to plus Q charge. Potential at P due to plus Q charge. ताले कितना गला? ताले V2. ताले V2 is equal to 1 by 4 pi epsilon 0 Q by एटा कितना गला BP. Q by BP. ताले this can be written as है ना? ताले मैं कौन लिख परिवा? 1 by 4 pi epsilon 0 Q by BP. BP is equal to R minus A cos theta. Clear? Now find the total potential. देखो चुनावे. Now find the total potential. ताले using the principle of superposition. ताले total potential. है ना? ताले total potential at P using principle of superposition. Total potential at point P, ताले V at point P is equal to कितना गला V1 plus V2. Yes, the total potential at point P कितना गला V1 plus V2. ताले you can write V1. ताले V1 है ला कितना minus 1 by 4 pi epsilon 0 Q by R plus A cos theta and plus 1 by 4 pi epsilon 0 Q by R minus A cos theta है ना? A cos theta. Clear? ताले potential at point P is equal to V1 plus V2 using the principle of superposition. That is V1 the minus 1 by 4 pi epsilon 0 Q by R plus A cos theta. Then V2 that is equal to 1 by 4 pi epsilon 0 Q by R minus A cos theta. Then what happens? What do you get? Then V is equal to potential at point P, Vp is equal to कितना गला? We take common Q by 4 pi epsilon 0. Q by 4 pi epsilon 0. Yes. Then we consider the positive sign first. Q by 4 pi. Then this 1 by R minus A cos theta. Then the negative sign 1 by R plus A cos theta. Clear? Then this is equal to Q by 4 pi epsilon 0. Yes. Then कितना गला है? The LCM is A minus B into A plus B, that is equal to A square minus B square, A square cos square theta. Then it is R plus A cos theta. Then this is minus of this minus A minus plus A cos theta. Clear? है ना? तले R plus A cos theta minus तले minus R minus plus, this cancel out, R cancel out. Then we get 2A, that is like Q by 4 pi epsilon 0 2A cos theta divided by S R square minus A square cos square theta. Clear? So this can be written as 1 by 4 pi epsilon 0. Then we take cure 2AQ cos theta divided by r square minus s square cos square theta. Clear? Then here 2aq, that is your dipole moment. Then we can write so this is equal to potential at point P, Vp is equal to kete gala 1 by 4 pi epsilon 0, yes 1 by 4 pi epsilon 0, then 2aq, that is the dipole moment P, then P cos theta divided by r square minus s square cos square theta. Clear? Well, this is the potential at point P due to a dipole. Clear? 1 by 4 pi epsilon 0 P cos theta divided by r square minus s square cos theta. Clear? This is the general expression for the potential at point P due to a dipole. Now we apply the special condition. कौन special condition? तो for a short dipole, short means small dipole. If small dipole means A and B are very close to each other. So if A and B are very close to each other, then for a short dipole, then A is very very small as compared to R. If A and very close, then 2A is very small, then A is very small as compared to R. So if A is very small as compared to R, then R S square is very small as compared to R square. For an example, suppose we consider A manekara 0.1 and R manekara 100. Yes, A ela 0.1, R ela 100. Now squaring this, tale kete gala eta? Tale aku squaring jodi kariba A square is equal to 0.01. Clear? Tale ethi kete jibo? Tale R square is equal to kete gala? 1 2 3 4. Tale kon paile? Tale when A is very small as compared to R, then A square is still smaller than R square. So S square is neglected as compared to R square. Tale as A is very small, tale S square is neglected. X square is neglected. That implies tale R square minus S square cos square theta is nearly equal to kete gala R square. That S square is neglected, so this term is neglected, so R square minus of S square cos square theta is nearly equal to R square. So what about P? Potential at P? Now for a short dipole, the potential at point P we can write yes 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0. Then P cos theta is P cos theta divided by that is equal to R square. So this is the potential at point P for a short dipole, and this is the general case. The potential at a point due to any dipole, and this is the potential at a point P for a short dipole. Clear? So here the potential at point P for a short dipole 1 by 4 pi epsilon 0 P cos theta by R square. On which factors the potential depends? So here the potential is inversely proportional to R square. Clear? The potential at point P is inversely proportional to R square. Clear? In a point charge, jadale point charge thila potential kon thila? Yes, for a point charge 1 by 4 pi epsilon 0 kon thila? Q by R. Potential is inversely proportional to R, but here inversely proportional to R square. जेमिति आमे इलेक्ट्रिक फील्ड रे देखुतले for a point charge electric field is inversely proportional to R square, but for a dipole it is inversely proportional to R cube. Similarly, एठी आमे देखिले potential at a point is inversely proportional to R, and potential at a point due to a dipole it is inversely proportional to R square. Clear? So if I draw a graph, जदि आमे ग्राफ टाणिबा, yes, so this is the graph R and this is your potential. So कोन हबा ग्राफ? This is more curved than this. This is the more curved. It is inversely proportional. सेठी हमर कोन थिला potential at point P रे? So this is a flat rectangular hyperbola. So this is a flat, but this is not a flat. Its slope is more than that. Clear? So this is inversely proportional to r and this is inversely proportional to 1 by r square. Clear? So this is your electric potential at a point due to an electric dipole. Now we find the special case if the point P is lies on the axial line and point P lies on the equatorial line. Hello? I mean the special case. Clear? The special case special case ಅಲ್ಲ the point P lies on axial line ಅಲ್ಲ ಹೇಗಿರಲ್ಲ P lies on axial line. Clear? So what do you mean the P lies on axial line? Axial line kaha kahitila the line joining the two charges is known as the axial line. This is your axial line. Eta hela tomara axial line. Suppose the point P on axial line, mane karo P is here. Suppose P is here. Tal kon hobo? When the P is on the axial line, then theta is reduces to 0. Clear? Tale P lies on the axial line. That implies tale here theta is equal to 0. If theta is equal to 0, tale what is the dipole? What is the field potential? Tale potential at point P kete gala 1 by 4 pi epsilon 0 P cos theta by r square. Tale P cos theta means 0 by r square. Tale cos 0 is equal to 1. Tale this is equal to 1 by 4 pi epsilon 0 P by r square. Hala? Tale the potential at point P is kete bhala? Tale due to the dipole, if the point P is on the axial line, tale potential kete la 1 by 4 pi epsilon 0 P by r square. Clear? Same thing ame bahar kariba potential if the point is on equatorial line. What do you mean by equatorial line? That is the perpendicular to the axial. Tale suppose P is here. This is the point of observation. P is here. Tale kon hobo? If the P is here, that means theta is kete gala 90 degree. Tale second case hela the point P on equatorial line. Second case hela kon P on equatorial line. P lies on equatorial line. Equatorial line. Clear? If P is on equatorial line, then in this case, what is the theta? 90 degree. Then here, theta is 90 degree. If theta is 90 degree, then what is the potential? Now 1 by 4 pi epsilon 0. Yes, P cos 90 divided by r square. Cos 90 is 0, then this is equal to 0. Yes, this is 0. Then what do you mean? The potential at any point on the equatorial line. So equatorial line over is a jagare point here. At anywhere on the equatorial line, potential is 0. So it is 0 potential line. 0 potential line. The equatorial line is a 0 potential line. At each and every point, jodi point nena kahi, whatever may be the position of the point on the equatorial line, the potential is 0. So it is known as the 0 potential line. Clear? So it would have a question kari pariba in case of electric dipole. The potential on the equatorial line is 0, but the electric field intensity? What is the electric field intensity at any point on the equatorial line? Not 0. The electric field intensity at any point on the equatorial line is 1 by 4 pi epsilon 0 P by r cube. Clear? Seta kon thila P by r cube. Tale ame kon janile? It is possible the potential is 0, but there is a presence of electric field. Yes. Electric field thai potential 0 hei pare. Question as paribo, is it possible a point where the potential is 0 but there is an electric field? Yes, it is possible if a point is on the equatorial line of a dipole. তাহলে ডাইপোলের ইকুয়েটোরিয়াল লাইন উপরে যে কোন পয়েন্টে there is a field but potential is a 0. Clear? তাহলে this is your electric potential due to an electric dipole. तो एबे हम देखिबा the relation between electric potential and electric field intensity. हला the relation between electric potential or potential difference and electric field intensity. Relation between electric field intensity, electric field intensity and potential difference বা potential electric potential হলা বা potential difference electric field intensity and potential difference. What is the electric field intensity? Relation between the electric field intensity and the electric potential at a point, but potential difference between the 2 points in an electric field. How can you find out the relation? Now we consider a test charge here. Suppose this is a charge. कारण हमें field से the relation बाहर कर से कार potential electric field और potential केते बड़ा होगा ना if there is a charge. Without a charge there is no field, and if there is no field there is no potential, no field intensity. So now we consider this is a source charge plus Q. If there is a source charge, then this is the field which is radially outward. This is the radially outward. This is the lines of force. If a point charge is here plus Q, then the field is radially outward. Now we consider this is a field line. Suppose this is a lines of force. It is an electric lines of force. On the electric lines of force, now we consider 2 points. Let it be A, and this point is B, which is very close to each other. Let it be DR. We consider this distance between the A and B is very small, that is equal to dr, and the electric field intensity within this is assumed to be constant, and this here the field intensity is E vector. This is the direction of E vector because this is the source charge is positive. If the source charge is positive, then the field at point is directed away from the charge. Now we consider, now we put a test charge here. We put a test charge here. Then move the thaleti kon haba ame aku kon kariba move toward this. Tala how much amount of work is done? Tala bartan dekhiba ye q0 upare kete force padila, because there is a q0 is present in the field of a field strength hela E. Tala there is a force on the ka upare test charge q0. Likhiba consider a point charge. Consider a point charge plus Q. Consider a point charge plus Q, which produces a radial field, which produces an electric field, which produces an electric field, that radially outward. Clear? Now consider the 2 points A and B on one of the line. Lines of force. Consider 2 points. Consider 2 very close points. Consider 2 very close points A and B, separated by a distance कहते हैं R, dr, separated by a distance dr, separated by a distance केते ला dr जेतु this distance is very small and the electric field is a point function तो एठी आमे dr नेले काहे कि small because जेतु एठी कोन अछि field is points function जेते आमे जेते दूरे दूरे जिवा field कमी कमी जिवो किंतु we consider a very close to points assume that the field intensity is constant within this 2 points A and B हला तो सेट पे आमे कोन नेले very close point नेले हला तो now put a test charge at A. Now put a test charge at A. हला तो put a test charge at A. हला now put a test charge at A. तो let it field कहते नहीं छे we assume the field intensity from between A and B is constant that is equal to E. तो now put a test charge plus Q हला test charge plus Q at A. So what is the force? The force on the test charge. The force exerts on the test charge. The force exerts on the test charge S. कितना हुआ? The force exerts on the test charge F is equal to कितना गला? ना Q naught into E. कारण जेहेतु E is equal to F by Q, we know the electric field intensity is equal to F vector by Q naught. So F vector is equal to कितना गला? Q into E. So this is the force and this force is directed outward. एबे मैं कौन करीबा move the charge towards B. हला तले if dW be the small displacement, small work. तले if dW be the small work done to move the charge go to now from A to B हला हमें कौन कले A to B को हमें आनिले against the electrostatic force against the force के F vector against the force F vector हला तला हमें force रो against हमें कौन कले charge को move कले towards करे B at तला how much work is done dW now find out तले dW is equal to force vector dot displacement F dot dr तला एटी कौन अछि the force and displacement both are in opposite direction तले force vector this is directed outward along the direction of the field and the displacement is from A to B that is the towards the charge so that is this is equal to minus F dr why it is minus because the angle of separation is 180 cos 180 ala minus 1 tale minus F dr what is F is equal to QE then we can write Q E naught into dr ba you can write nale emti lakha tale amara eti kon thila F vector is equal to QE tale you can write tale Q into E naught into dr here E naught and dr both are in opposite direction we can write Q E naught into dr because angle is 180 tale dW is equal to minus Q E naught into dr clear tale this is the amount of work done go to bring the charge from A to B suppose the potential difference between A to B is equal to mane kara V suppose let V the potential difference null VAB ले जाओ the potential difference between कहाँ का भितरे A and B yes है ना let VAB is the potential difference between A and B तो what is VAB तो we can write तो VAB is equal to तो क्या था वो तो potential difference VB minus of VA तो VB minus of VA है ना तो this is the potential difference between कहाँ का भितरे ना A to B तो how much work is done to move the charge yes तो by using the potential W by Q naught तो इधर कौन लिखिवा तो dW is equal to क्या देला তাহলে this is called, we can write তাহলে W A to B by Q naught by definition ହେଲା the potential difference is equal W A B by Q naught তাহলে W A B কেতে হইগলা that is called V A B into Q naught তাহলে that implies ହେଲା তাহলে V A B into Q naught তাহলে এটা হলো W A B তাহলে W A B is equal to V A B into Q naught ହେଲା তাহলে V A B কি না potential difference we can write this is equal to dV into Q naught ହେଲା তাহলে যেহেতু this is the potential difference and the points A and B are very close then this potential difference কেতে নেলি আকো মনে করে কোন নেলি কেতে dV let তাহলে DAB কেতে গেলা dV into Q naught ক্লিয়ার তাহলে এটি ওয়ার্ক ডান কেতে পাইছিলে এটা হলো ওয়ার্ক ডান তাহলে দিস এবং এটি মধ্যে সেই দ্যাট ইজ ইকুয়াল টু A to B ହେଲା তাহলে কেতে হইଯିବ এটা মধ্যে সেই আমি লিখি পারিবা দিস ইজ ইকুয়াল টু DW is equal to dV into Q naught তাহলে this is your equation 2 and this is your equation 1 good this is the equation 1 তাহলে dW is equal to minus Q E naught dr dW is equal to dV into Q naught from the equation 1 and 2 we get from equation 1 and 2 we get hello from equation 1 and 2 we get what we get দেখো তাহলে minus yes Q naught E dr is equal to dV into Q naught dV into Q naught this Q naught is cancel out তাহলে E is equal to minus dV by dr clear তাহলে E is equal to কেতে হলা minus dV by dr this is the relationship between electric field intensity and dV means কি potential difference clear তাহলে এটি কোন পাইলে E is equal to minus dV by dr তাহলে here dV by dr this is known as the potential difference with respect to the distance A B distance this is known as the gradient hala so that is the change in a function with respect to distance is known as the gradient so dV by dr is known as potential gradient dV by dr is called potential gradient change in potential with respect to distance तब का है potential gradient clear তাহলে এটি আমি কল পাইলে তাহলে E is equal to minus of কেতে হলা potential gradient clear thus তাহলে এটি আমি কল পাইলে তাহলে electric field intensity is equal to the negative of the potential gradient hala the electric field intensity is kete gala negative of the potential gradient this is the relation between electric field intensity and the potential difference hala tale if delta V and delta R jodi ami likhi pariba in this case dV and dr eta la potential difference this is the distance of separation if dV R and dr hala with the potential difference এটা are the potential difference and এটা কি হলো distance of separation distance of separation 2 points then we can write electric field is equal to minus delta V by delta R we can write here delta V by delta R clear so this is all about your the relationship between the electric field intensity and the potential gradient clear then one more class already the next I will discuss about the electric potential energy hela egala amar electric potential bishay dekhiba the next class we will study about the electric potential energy clear